Hi, in this video, we are, g- we are going to see how exponential equations can be applied to real life situations. So we have a question, example question over here. The temperature T degrees centigrade of a hot drink T minutes after it is made is given by T equals to 75 e to the power of minus 0.02 times T plus 20. This capital T is the temperature and this small t is the time in minutes. We need to find the temperature of the drink when it was made. Now, this equation models the temperature of the drink after it was made. After it was made, we need to find the temperature of the drink when it was made. So, this indicates that we are talking about the initial time, that is 0. So we have to find the temperature when T is 0. So when the time value is 0, what is going to be the value of the temperature of the drink? So 75 e to the power of minus 0.02 times 0 plus 20. E to the power of 0 is 1. So 75 plus 20, that is 95 degrees centigrade. So in the start, when the drink was made, its initial temperature was 95 degrees centigrade. Now we need to find the temperature of the drink when T is 6. So in part B, when T is 6, let's find the temperature. 75 e to the power of minus 0.02 times 6 plus 20. So if we do the math, it comes out to be 86.5. So when the time was 6 minutes, after 6 minutes, the temperature of the drink is 86.5 degrees centigrade. So this tells us what is happening. If we leave the hot drink in the room, it's going to be affected by the surrounding temperature and it's going to lose heat, and in result of that the temperature of the drink is going to go down. So initial temperature was 95 degrees centigrade. After 6 minutes the temperature reduces down to 86.5. Now the next part says find the value of time when the temperature is 65. So we want to find out at what time, after how many minutes is the drink temperature is going to be 65 degrees centigrade. So the formula or the equation was T equals to 75 e to the power of minus 0.02 T plus 20. T value is 65. We are going to solve this exponential equation. 75 e to the power of minus 0.02 t equals to 65 minus 20, that is 45. E to the power of minus 0.02 t equals to 45 upon 75, which is 0.6. So e to the power of minus 0.02 t is equal to 0.6. Now we need to apply natural log on both the side and bring this power down. So it's going to be minus 0.02 times t times ln e. Ln e is 1. So t comes out to be equal to ln of 0.6 divided by minus 0.02. Ln of 0.6 is also a negative value, divided by a negative 0.02. It's going to be 25.5. That is in 3 significant figures. So after 25.5 minutes, the temperature of the drink is going to go down to 65. Okay, let's consider another example. In this example, the question says a species of fish is introduced to a lake. The population n of the species of fish after t weeks is given by the formula n equals to 500 e to the power of minus 0.3 times t, where t is the time in weeks and n is the population of the fish. Find the initial population of the fish. Okay. So the first part says we need to find the initial population of the fish, which means when no week had been passed, which means when t is 0, So n is equals to 500 e to the power of minus 0.3 times 0, which is 500. So initial population is 500 fishes. Part B says estimate the number of population of these fish after 6 weeks. So when t is 6, what's the value of n? So 500 times e to the power of minus 0.3 times 6. If you use the calculator to solve this, we get 82.649. That is 82.6. So when after t equals to 6, 83 fishes are going to be there. If we convert this into an integer value, 83 fishes are going to be there, or 82 complete fishes are going to be there. Now part C says estimate the number of weeks it takes for the number of these fish to have fallen to half of the number introduced. Half of the number introduced, so initially the number of fishes introduced was 500, so half of them would mean 250. So how much time is it going to take, how many weeks is it going to take to reduce down the number to 250? So we are going to solve this equation. 250 divided by 500 is half. Applying ln on both sides. So I can express this as ln e to the power of minus 0.3t equals to ln of half. We can bring down this power here, minus 0.3t times ln e, and ln e is 1, and this is equals to ln half. So t is equals to ln half divided by minus 0.3. ln half is also going to be a negative value, so the final answer comes out to be 2.31. that is 2.31 weeks. So after 2.31 weeks, the population of the fishes is going to reduce down to half. Thank you for watching this video.